Okay, I think it's time to get started. So hello everyone and welcome to our maths webinar. This is the second in our introduction to the Bridge the Gap series. I'm Vishan Vora and I'll be taking you through this today. So let's start off with a brief session plan. So we'll be starting off with a little bit about us, who are the three tutors and what is Bridge the Gap. Then there's a little bit of housekeeping, and really this is just that we ask that you keep your mics off and your videos off throughout the duration of this call. And then we'll be looking at some exponentials and logarithms. So here's a little bit about us. So the Three Tutors is a fairly new tutoring company. We were established in 2024 and we're focused on personalized tuition. And this involves using adaptive teaching catered to your learning style. Let's meet your tutors. So we all have a strong academic track record across GCSEs, subject Olympiads, personal projects, and A-level so far. We're all passionate about subjects and giving the best tuition to you. We all have all A-star predictions for our A-levels, and you can read more about us on the website. So that's Arib, there's Samuel, and there's me, Vishan. So a little bit about the Bridge the Gap course. So are you looking for a refresher of Year 12 content, or are you looking to dip your toes into uncharted content, stuff you haven't seen before, haven't quite heard of before? Or if you're looking to just deep dive straight into the new Year 12 material, then the Bridge the Gap course is for you. It's a 6-week course, it will be small groups, and we'll be taking you through the first few months of these A-level subjects. This is the perfect moment, an opportunity for you to taste test your subjects too and find out about what each subject involves. So if you are interested, do fill in the interest form linked at this QR code. It's also linked on our website and in our social page bios. So that's all for the presentation for now. We'll now be looking at some exponentials and logarithms. So let's have a look at our learning objectives. So by the end of this session, we should be confident with GCSE indices. We should be able to visualize exponential functions, describe the asymptotes of a graph, and define logarithms. We'll also look at some A-level future application. So let's dive straight in. GCSE indices. An index, or an exponent, as some people call it, is defined as raising a variable to a power. But what does this actually mean? So let's take the example 2 to the power of n. What this means is 2 is being multiplied by itself n times. For example, if the value for n was 4 in this situation, then there would be 4 2's in that expression. Here are some general rules that you'll be familiar with from GCSE. So when we've got the same base and different powers, and they're being multiplied together, we can add them. So add the powers. So that would simplify to a to the n plus n. Quite similarly, with division, we subtract the powers. So a to the n, take away n. When the powers are split with brackets, we multiply them. So a to the m n, or m times n. With negative powers, these represent reciprocals. So 1 over a to the m. And with fractional powers, they represent roots and raised powers. So that would be root n, n root a, or to the power of a, m. And as you would know from GCSE, a to the power of 0 is just 1, anything to the power of 0 is 1, and anything to the power of 1 is just itself. So with the first example, a squared multiplied by a cubed, the same base, and we're multiplying them. This gives us a to the power of 5. So a to the 2 plus 3, 5. When we're dividing them, we subtract them. So we get a to the power of 1. When they're split with brackets, we get a to the power of 4x because we just multiply them. And as I said earlier, negative powers represent reciprocals. So that's 1 over 2 to the power of 3, or 1 over 8. And with this negative fraction, it gives us the 5th root of a to the power of 4, all over, well, all underneath rather, 1. So we should get 1 over the fifth root of a to the 4. And again, as I said earlier, anything to the power of 0, no matter how large, no matter how small, gives us 1. Okay, now let's move on to some exponentials. Now, this might be a new concept to some of you. An exponential can be defined as a change with changing speed. And the way I like to think of this is the gradient is constantly changing. Let's look at an example, and we'll look at this graphically. So if we take the graph y equals 2 to the x, 2 to the power of x, it looks somewhat like this. As you can see, it starts in the top left quadrant and it asymptotes at 0. What this means is that it approaches 0, but doesn't quite get there. So that is an asymptote. And it then goes towards infinity in the top right quadrant. Similarly, here's another example, y equals a half to the power of x. And that looks very similar, just reflected in the y-axis. So that is y equals a half to the power of x. Both of these intercept the y-axis at the same point. And some of you might be able to tell that that point is 0, 1. And the reason for this is anything to the power of 0 is just 1. So those are our graphs. Sometimes in exams, we can be given this equation and be asked to work out the value of y, given the value of x. For example, let's take the equation earlier, 2 to the x. Let's say we're given the value of x as 1. A question might ask us to determine y. And that's relatively simple. You just substitute it back into the equation. So 2 to the 1, we get 2. Let's say x was 2 this time. We get y equals 2 squared. And that gives us 4. But what if we were given y and we weren't given x? So let's say they told us y is 4. And they asked us to determine x. Can't quite substitute it. We could use some trial and error. That's not the most efficient way to do it, though. And that's where logs come in. Logarithms are described as a function that lets us rearrange exponentials. So let's stick with this example, y equals 2 to the power of x. And assuming that they give us y equals 4, and they ask us to determine what x is in the question, we could use a logarithm function for this. And that would look like this. Log base 2 of 4 gives us x. What does that actually mean? So logarithms are formed by using the keyword log, standing for logarithm, a base number, which represents what the base of the power would have been in the original equation, an argument, which goes inside these brackets, and the argument refers to the original answer of the equation, in this case y, and a return value of the power. So in this case, x. As you can see, 2 is the base of this equation, so 2 goes in the base. 4 was the original answer of this equation, so 4 goes in as the argument. And x was the power, so we get x as the return value of this equation. But as with indices, there are some laws about these logarithms. Let's look at what these log laws are. So starting off, if you've got 2 logarithms with the same base, we can multiply these arguments to represent an addition statement. For example, with log base b of m plus log base b of n, we can multiply these to get just one logarithm. So log base b of m n. Similarly, with subtraction, we divide them. So as you can see, there seems to be a bit of a trend coming from indices. The log base b of m divided by n. When there is a power that hasn't been separated from the argument inside a logarithm, we can remove it. So k multiplied by log base b of m, and that would give you the same answer. And very similarly, very similar to the index laws earlier, log base b of 1 or log base anything of 1 gives us 0, and log base anything of anything always gives us 1. And we can check these using our index laws. So b to the power of 1 gives us b. Yeah, that checks out. B to the power of 0 gives us 1. So yes, both of those check out. Let's start practicing some simplification. So log base 2 of 5 plus log base 2 of 10. We know that's going to end up with one logarithm with the same base from earlier. And because there's an addition, we'll be multiplying the arguments. So we get 5 times 10, and that's 50. For log base 2 of 4x, it's the same rule as above. This time we're just splitting them. So we can split them like this. I'm taking factors 4 and x of 4x. So log base 2 of 4 and log base 2 of x. That simplifies further. I know that 2 to the power of 2 is 4. So that's 2 plus log base 2 of x. And for number 3, log base 3 of 9, take away log base 3 of 27. We can divide them. We get log base 3 of 9 over 27, or log base 3 of 1 over 3. And that again simplifies further. We just get minus 1 from that. Here's a slightly more challenging question now. This contains 3 logarithms, 3 parts of the expression that we'll be simplifying. So let's give this a go. Log base a of 36, we can't really do anything with that yet. What I have noticed though is that there is a half over here, a 1 over 2. And I know from my log laws that that would have come from here, because that would have been removed. So we can put that back there and see if it does anything for us. We get log base a of 256 to the half. And I know that that just means the square root of 256 from my log laws. So I know that that's 16. As for the next part of the expression, we could either remove the entire minus 2 and put that to the power there, or we could just remove the positive element and retain the negative as part of the subtraction of the statement. Let's do that. Let's remove the positive. So we get log base a of 48 squared. That simplifies to log base a 2,304. And we had log base a of 36 earlier. This is obviously still negative, that part of it, because we only removed the positive element. And these are still being added together. Let's split it again, just down here. Do the addition part of it first. So log base a of 36 plus log base a of 16 simplifies to log base a of 36 times 16, which is 576. And from that, we're subtracting log base a of 2,304. Because it's a subtraction, we can divide these arguments. So we get log base a of 576 divided by 2,304. And we get log base a of 1 over 4. So all of that above just simplifies to log base a 1 over 4. Let's have a look at some future application of this, some further information you'll be studying during your A-level course. We'll be simplifying and solving more complex equations. We'll be doing the above in context too. So for example, you might be looking at some compound interest. You might be looking at a graph. We'll also be looking at something called reduction to linear form. And you'll also be looking at some more specific logarithms like the natural log or ln, and that refers to functions of e or Euler's number. So that is now the end of our maths webinar. Let's have a look at our learning objectives and see what we've learned. So we are now more confident with GCSE indices. We can visualize exponential functions and describe their asymptotes. We can also define what logarithms are and use them, and we know what's coming up in the A-level course. So thank you very much to those of you who attended the webinar today. If you do wish to contact us, then please use our email address, the3tutors@gmail.com, or our website. You can also stay in touch with us by keeping an eye on our socials. We are at the 3 Tutors on both Instagram and TikTok. A recording of this webinar will also be going live on YouTube later, in case you'd like to watch it over again and give some of the questions a bit more practice. If you are interested in learning a little bit more about the A-level, then do join our Bridge the Gap course. You can sign up for this on our website. We'll be looking more into these topics that come up at the start of your A-levels, and we'll be diving right into that content very soon. So thank you very much for coming. I was Vishan Vora. This was 3 Tutors, and we hope to see you soon.